All right, in the first video of this section, we introduced APT, arbitrage pricing theory, by discussing how any risk-adjusted profit will be eventually arbitraged away until every asset lays upon this line that measures the relationship between risk and return. Well, what happens about idiosyncratic risk, firm-specific risk? Recall from Chapter 8 when we looked at this in a single-factor model. Recall what happens here. We got the return for the portfolio is just equal to the alpha of the portfolio plus the beta of the portfolio times some systematic risk event, right? Plus this error term, all right? Recall that what this used to be was alpha for the portfolio used to be the expected return for the portfolio, right? Alpha used to be the expected return for the portfolio. So the return for the portfolio is just what we expect it to be plus some error term. And then all of a sudden we implemented these risk factors that exist. And beta P represents the exposure to these risk factors. All right. So just note that that alpha has important meaning. We'll talk about that one next. However, just a reminder, what happens to the idiosyncratic risk of a portfolio in the under this idea of arbitrage pricing theory? Recall the return of the portfolio is just equal. Let's make the assumption of well, we have weights here, okay? So the return of the portfolio is just equal to the weighted average of each asset in that portfolio. That's here on the left-hand side of the equation. And on the right-hand side of the equation, we have the alpha of the portfolio is just equal to the weighted average of the alphas of each individual asset in the portfolio. The beta of the portfolio is equal to the weighted average of each asset in the portfolio, the beta of each asset in the portfolio. And the epsilon, or the error term, is just equal to the weighted average of each epsilon, okay, the error of each asset in the portfolio. Again, under the assumption of naive equal weighting, we just are adding up all of the stocks in our portfolio and dividing by n. In the previous module, we talked about how we obtain optimal portfolios. Here, we're just equally weighting them, averaging them, equal weighted averaging, okay? And what happens? We just get that the return for the portfolio is equal to the average alpha for the assets in the portfolio plus the average beta for the assets in the portfolio times the systematic risk event plus the average epsilons in the portfolio. The portfolio variance is equal to, this is the variance of the portfolio, is equal to the variance of the first part plus the variance of the second part plus 2 times the covariance, but we know there's no covariance between the error term and the exposure to the systematic risk event. The error terms are independent of those systematic risk events. So what we have here is we have the variance of the portfolio is equal to, this is the systematic risk, the exposure of the portfolio squared to the risk event times the variance of the risk event plus the idiosyncratic risk, which is just the variance of the epsilon terms. Under the idea of the naive approach of equal weighting, I'm going to multiply both. I'm going to multiply the weights or raise the weights to the second power, okay? And then I'm going to multiply that by the variance of the epsilon for each asset I. I'm going to pull one of these 1 over n's out, and what I have is the average variance of epsilon I times 1 over n, and in the limit as n goes to infinity. So if my portfolio is well diversified, as n goes up, the idiosyncratic risk goes away. So not only are any risk-adjusted profits, inefficiencies we'll call them, not only are risk-adjusted profits arbitraged away, but also any idiosyncratic risk is diversified away. Again, suggesting that the only thing that matters is that systematic risk.